Hello, in this modern OpenGL tutorial, we're going to be looking at implementing a camera class so we can actually move around our world using the keyboard for essentially a walking style of movement and using the mouse to look around. Because at the moment it's looking good, but as we add more objects to it and we want to see from different angles, we don't want to have to code in where we're starting or where the objects are starting and rebuild and rerun the application. We want to be able to freely move around it. So there are a few things we're going to cover in this video: creating the camera class, obviously implementing that into our current application. We're going to be covering, but at the moment what we've got is this single cube created. We're going to basically get rid of most of this and use a simple array of vertices and use a loop to actually draw multiple cubes. So it'll be a lot better when we're actually moving around. Instead of just moving around one cube, we'll see multiple cubes, which will be fantastic. So a few prerequisites: we're using the source code from the previous videos, which was on projections and coordinate systems. If you haven't checked it out, please feel free to have a look at that. It's in this series. You can get the source code from the GitHub link in the video. Another thing to mention is this is using GLFW as the framework. We will be using some GLFW code in here, only for the input of what we're doing. But what I've got is a link to the GLFW input guide, the SDL input guide, and the SFMI input guide, and it's really easy to swap it over because the camera class itself isn't going to have any framework specific code. It's only going to be in the main, which is going to be used to detect the input, so you'll be easily able to switch it over, and all those links will be in the description. One last thing, as usual, this video is based on the work of learnopengl.com and open.gl. So now let's get into this video. The first thing we're going to do is add a new file, and this is going to be our camera class. So it's going to be, I'm going to create a header file, add it to our target, and I'm going to call it camera. I'm only going to have a header because the methods that we're going to be implementing are very simple methods, but you can abstract it out into a separate CPP file if you want to, and I'll recommend checking that out as well, trying to do that, because that'll be a great way of learning. So let's just zoom in a bit more, let's scroll to the left slightly so we can see the number lines. So first of all, we're going to get rid of the code that we've already got and put hash pragma once, just a simpler version. Now it doesn't work on all compilers, but most compilers will support this. We're going to do hash include vector. We're going to be using the vector class for stuff like positioning, X, Y, and Z, that sort of stuff. We're going to do hash define GLEW underscore static, because we're going to be using GLEW in here, which we've already linked up to our project. Again, another thing I want to mention, even though I'm doing this on a Mac using Xcode, the coding has no relevance whatsoever to the OS that I'm developing on or the IDE that I'm using. So you'll be good to go if you're on Linux, if you're on Windows, if you're using Visual Studio. As long as the project's set up, you're good to go. So we're going to do include, or hash include gl /glew.h. We're going to include some OpenGL mathematic libraries, so glm /glm.hpp, hash include glm gtc /matrix underscore transform.hpp. One last thing I'm going to do is create a bunch of empty lines, and the reason I'm doing that is just so I can easily scroll up and down and position the code where I want it, so it's easier for you to see it and easier for me to code as well. So first of all, we're going to create an enumeration. So enum camera movement. So this is just going to have forward, backward, and left and right, which we're going to use to be able to find out which way the user wants to move the camera. Essentially, which way does the user want to walk. You can think of it like that. This needs to have a semicolon, and we're going to put forward. You can put like E forward or E underscore forward, whatever naming convention you want to use. That's A-OK. Backward, left, and finally right. Scroll down a bit. Now we're going to create some constant camera values for the yaw, pitch, the speed of the camera movement, the sensitivity, and the zoom as well. We're not really going to be having methods for these apart from the zoom, but you can have methods for all the other ones. You can create getters and setters. Recommend doing that as an extra task. It's a great way of learning, and you'll be able to use them later on. So we're going to put const. Obviously at the moment, because we're using a constant, you won't be able, obviously, be able to modify it, but if you do want to modify it, that's not a problem as well. But these are the default values, so you wouldn't specifically be manipulating this particular variable. You'll be manipulating the variables within the camera class, which we're going to create in a moment. So GL float your equals minus 90.f, and for the const GL float pitch equals 0.0f, const GL float, this is going to be speed, equals 6.0f. This is just a value that I've determined that works pretty well using the code that we'll be writing, but you can change this up, make it slower, make it faster, whatever you want. Simple stuff. Higher is faster, lower is slower. GL float sensitivity, so sensitivity, I wonder what that's saying. Just installed Mac OS Sierra, so just saying, do you want to have a quick tour of it using our little guide? No, I'm okay. There we go. So GL float sensitivity equals 0.25f. So this is just a sensitivity of our mouse movement. Again, higher the faster the mouse movement, and lower the slower the mouse movement. Now we're going to put const GL float zoom. The zoom value is the field of view. So 45 degrees is very common. A higher value would basically mean a taller screen. It's essentially what the old Doom games were, so you can try that. And we're going to have a getter and setter for the zoom, because what we're going to do is when we scroll our mouse, we'll be able to zoom in and out to be able to change the field of view. In a real game, you probably wouldn't do that, and in the next video, I'm actually going to remove that feature, but it'll just be to illustrate the field of view, plus show you how to do the scrolling as well. So next thing we're going to do is class camera. I'm going to do public. So we're going to do a constructor with vectors first, and a constructor with scalar values. So camera, we're just going to take glm : vec3, and this is going to be position, and it's going to equal to glm vec3 0.0f, 0.0f, and 0.0f. So it's just got some values there as default. We're gonna do the up vector as well. We just need to specify the up vector so we know the relationship of our world and our camera. So we're gonna put glm : vec3 up, and this is gonna equal to glm : vec3. Let me just scroll over slightly. Vec3 0.0f, 1.0f, and 0.0f. And what we're going to do now is do, oopsie daisy, 1 second. Vec3, we got the up vector done. Now we're going to do the yaw float, so like the actual yaw value, so GL float yaw equals yaw. And for the next value, what we're going to do is do the pitch, so GL float, got to move over slightly, GL float pitch, move all the way back again, GL float pitch equals pitch, and what we're going to do is put colon front GLM colon vec3 0.0f 0.0f negative 1.0f for a comma. We're going to do movement speed, and what we're going to do is put speed comma mouse sensitivity, am I spelling right? Sensitivity. It's always these words that you can never figure out how to spell. And this is going to take the value of our const that we created before, so sensitivity. I'm going to do comma zoom, and in here it's going to take the const of zoom. So now it's going to move over, and now we're just going to quickly implement our camera constructor. So this position equals position. We haven't created these variables yet, but we will in a moment. We'll do this world up equals up. This yaw equals yaw. This pitch equals pitch. This update camera vectors. We haven't implemented this method yet, but we will be very soon. And now that we've done this particular constructor, now we're going to do the constructor with scalar values. So what we're going to do is do camera, and we're going to do GL float pos x equals, sorry, not assigning anything, we're just doing GL float pos y, GL float pos z, GL float up x. And what I'm going to do is copy and paste this because it will save us some time. So this is going to be up y, up z. So now we're going to do the yaw value. So we're going to do GL, probably best if I move the screen over a bit. GL float yaw, GL float pitch, and now we're just going to do colon front. So we're going to get rid of this, move this over a bit. I'm going to put GLM colon vec3 0.0f. Let's move this back over again. 0.0f, 0.0f again, 1.0f, I mean negative 1.0f, And we're going to do comma movement speed, and this is going to be speed. Don't worry, all of this will become clearer to you as we create this class, so just bear with me. For now, sensitivity, this is going to be sensitivity, but just autocomplete does not want to work. Sensitivity, and the final one is doing the zoom. So zoom, and now what we're going to do is just implement this constructor. It's going to be very, very similar. So what we're going to do is just copy and paste this. Copy, paste. So instead of doing position equals position, we're going to be doing glm : vec3, and we're going to do pos x, pos y, pos z, and we're going to do the same for the up vector as well. Pos, no, not pos, we need to do up x, up y, up z. So we've got your pitch and update camera vectors. That's not a problem. So now what we're going to do is implement a getter for getting the view matrix, because this will return the view matrix that's calculated using Euler angles, and the lookup matrix. So what we're going to do is glm : a 4x4 matrix, and this is going to be called get view matrix. This we'll be using this in our main CPP. We're going to do return glm : look at this position, this position plus this front, this up. So yeah, so this is just stating where we basically want to be looking at, and yeah, we want to be obviously be looking front, and we want to be using the up vector as well, so we got it relative, and we'll be using our position. Now what we're going to do is just process some keyboard input, and using this this keyboard input will detect if we're going forward, backward, left or right, and we'll move in that direction. So we're going to do void process keyboard camera underscore movement direction. So this camera movement is the enum that we created above. GL float delta time. So this is the time between frames, so we can create frame independent movement, because the last thing you want is to have 60 frames per second, then suddenly dip to 30 frames, and then that to be half the speed. You want it to be the same speed. Obviously you won't look as smooth, but you'll still get a consistent movement, and that is what is important. So in here we're going to do GL float velocity, and this is going to be equal to the movement speed times by the delta time. So the movement speed, so let's just say that 5 for example, and the delta time is 0.1, that would be 0.5. So if it's a higher delta time, it'll be a higher movement speed. If it's a lower delta time, it'll be a lower movement speed. So it just keeps it all frame rate independent. Now we're going to do if forward equals direction. So are we moving forward? If so, we're going to do this position plus equals this front times by the velocity that we've already just calculated right here. Now let me just move the screen over a bit. Velocity And what we're going to do to make life easier, copy and paste this. It's not going to be an else if, and I'll explain in a moment why it's not an else if. We're going to do backward now, backward, and this is going to be set to this position, minus equals this time because we're moving back, not forward. This front times velocity, so it's the same. So copy and paste it again, and this is going to be set to left, and because we're moving left, it's going to be this position minus this right times velocity, and we're just going to duplicate this so we can change this to right, change this to, where am I looking? Here. Need to change this to a plus. So you might be wondering, why aren't we using a switch statement, or why are we not using an if else if else? For starters, if let's say you clicked the forward key and the left key, you want to be able to move sort of, essentially that would be northwest. You want to be able to move in that sort of direction, ignoring which way we're looking. So let's assume we're just looking north. You want to be able to move northwest. You don't want to have to press one key, then let go, then press another key. Likewise, if you're moving forward and you click backwards, you'll stop. So you don't want to be, going having to release keys. So that's the reason we're doing separate if statements. So next thing we're going to do is process the mouse movement. So this is going to be processing the input received from our mouse system, whether that's GOFW, SDL, SFML, and it will use an offset value so it can adjust the X and Y direction. So what we're going to do is void process mouse movement. So mouse movement GL float X offset. So this is just going to be essentially the difference between the mouse movements. Because otherwise, how do we know where we're moving? Is essentially the speed. That's the best way to think of it. GL float Y offset GL Boolean, and this is going to be constrain pitch. So are we constraining the pitch? And this is going to be equal to true, and that is it. Now what we're going to do first of all is just calculate the X offset, or just adjust that using our mouse sensitivity. So we're going to do X offset times equals this mouse sensitivity, copy and paste this, put a Y, offset times equals mouse sensitivity, that's fine. We're going to do this, your equals plus equals X offset, copy and paste this, and this will be this, not your, but pitch equals, sorry, not equal, it should just only be plus equals, should only be the 1, Y offset. Now we're going to check if the pitch is constrained. So we're going to do constrain pitch. So if constrain pitch, we want to prevent the user from being able to go out of bounds so the screen doesn't get flipped. Because if we move our mouse, or our sort of the way we look, to the left and to the right, if we go the left for so long, we'll loop back around. Same thing for the right directions, anti-clockwise and clockwise. Whereas when we're looking up and down, you generally only want to be able to look up by about 90 degrees, what your head essentially can roughly do. I'm actually doing it right now, you obviously can't see me. And then just look down roughly about 90 degrees, what your head can roughly do at your feet. You don't want to be able to just keep looping back around, because you start getting all sorts of different various problems, like gimbal lock is one of the issues. But in general, that's not the sort of movement that you have in games, because games are based on our real life and our constraints of the human body. So what we're going to do is, don't know, this is definitely not what I want. In here, we're going to check for the pitch. So if this pitch is greater than 89.0f. Then we're going to assign the pitch to 89.0f. If this pitch is less than negative 89.0f, we're going to, I think you can guess, assign it to pitch equals negative 89.0f. And the last thing we're going to do is just update the camera vectors. So this update camera vectors. So this is just going to update the front, right, and up vectors using the Euler angles that we've done right here. So I don't know why I was zoomed out for, because we still got plenty of code to write. Let me zoom back in slightly. Okay. So now that we've processed the mouse movement, we're going to process mouse scroll. So we're going to do void process mouse scroll. I'm going to put GL float. So we're only going to do Y offset. You can put X offset if you want to be able to detect the horizontal scroll. A lot of mouses don't have horizontal scroll, but quite a few new mouses, especially gaming mouses, dual productivity mouses, but generally speaking you probably only want to do Y, aka vertical scroll. So we're going to be detecting that. We can easily extend this method and this class in general to suit your requirements. So we're going to do if this zoom is greater than or equal to 1.0f and this zoom is less than or equal to 5.0f, then what we're going to be doing is taking away the offset. So we're going to do this zoom minus equals Y offset. Now we're just going to check if the zoom is below 1.0f now or above 45.0f, and then just lock it to 1.0f or 45.0f. So what we're going to do is if this zoom is less than or equal to 1.0f, I'm going to do this zoom equals 1.0f, and now we're going to do the same again for 45.0f. So if this zoom is equal to, no, greater than or equal to 45.0f, we're going to do this zoom equals 45.0f. And now we're going to create a getter for getting the zoom, because the zoom variable will be private. Actually, all the variables are private in this class. So we're only creating really the zoom getter simply because, well, the reason is that's the only one we're using outside of this class for now. But if you need to use something like the up vector or the yaw or the pitch or any of the other variables that we're creating, feel free to create getters and setters appropriately. So we're going to do GL float get zoom. I wonder if anybody watches Flash. I'm going to take a good guess that you probably watch Flash if you're watching this video. So just returning the zoom variable, and now we're going to do private. Finally, we're getting onto our variables that we've been referring to, and inside here we'll have the update camera vectors method because we're only using that within this class. So first of all, glm : vec3 position. We're going to put glm : vec3 front, glm : vec3 up, glm : vec3 right, and we've got one more vector which is the world up direction. I'm going to put glm ::, vec3 world up and up. Oh, my bad. One thing I just want to mention before I go on, that this tutorial does provide a lot of information. It definitely is a lot to take in, so feel free to watch the video again. Feel free to ask any questions you may have in the comments on our education platform, sonarlearning.co.uk, and we base these tutorials on the work of learnopengl.com and open.gl. Check out those websites for more in-depth written information about this video and what we're doing in this video, because they got nice diagrams on there, they got really in-depth sort of text going really in depth into all these different variables and these methods. So I can only briefly cover what we're doing in here because this video is already quite long as it is, and we are still only in the camera class. So feel free to check that out if you're confused about anything. I'm going to put GL float now. Your GL float pitch, GL float movement speed. All of these parameters that we've been creating are finally getting created now. I mean, being using up there are finally getting created now. So this is going to be mouse sensitivity, and the final variable is GL, can you guess? GL float zoom. And the last thing we need to do in this class is void update camera vectors. And when we're updating the camera vectors, we need to calculate the new front vector. So we're going to do glm : vec3 front. So this is going to be a temporary storage of it. We're going to do front.x equals cosine glm : radians this your, and we're going to multiply this by cos glm. Again, this is obviously some complex, not ridiculously complex, but it's obviously quite in-depth, the mathematical calculations here. So I would say check out those links that I said, learnopengl.com and open.gl. They covered these in really great depth, and it's amazing because they have great images on there which help illustrate the points that I'm trying to make and the actual calculation, what they're trying to do. So this pitch, and what we're going to do is front.y equals sin, and this is going to be glm : radians this pitch semicolon front.z equals sin glm : radians, and this is going to take this, you're going to multiply this by cos glm : radians, and this is going to take the pitch value, so pitch and we're done. You might be thinking, why is the sort of the values inside here very similar to the Z? Because that's on, I want to say on a similar playing field, but when you look at like the X, Y, and Z, it's like the Z and the X is sort of flat along the ground essentially, and the Y is sort of going up, sort of going away from it. But again, it's relative depending on how you're looking. Again, these calculations are explained more on those websites, so feel free to check them out. Now we just need to assign it to this front equals glm. We need to normalize this vector, so normalizing it just sets it to between 0 and 1. That's what normalizing is. Front. Now we also need to recalculate the right and the up vector, so we're going to do this right equals GLM colon colon normalize GLM colon colon cross this front, this world up, this up equals GLM colon colon normalize GLM colon colon cross this right, this front. So now we have finally done the camera class. I'm more than positive that there will be some mistake in here when we actually get around to compiling it and using it. So let me just save that. And now what we're going to do is go to our main.cpp. Yeah, we got IntelliSense. For some reason, no IntelliSense in here. I'd probably work on actually compile it. So in our main.cpp, we're going to start implementing the input stuff that we've been doing. So we're going to be using the GFW sort of input system. But again, feel free to check out those links for more GFW information, SDL and SFML information. First of all, we need to include our camera class. So let me zoom in right here. So hash include camera.h, and now for the width and the height, that is not a problem, but what we're going to do is actually take these out and put them here, because we're going to be using them outside of the main as well. We're going to rename them slightly. We're going to put screen underscore width, screen underscore height, and now let's just update everywhere we use these. So screen underscore width, screen underscore height, scroll down, viewport, so screen underscore width, screen underscore height. And I believe we use it one more time for the projection matrix as well. So screen underscore width, screen underscore height. You know what, I'm going to get rid of the orthographic projection. We're not using that anymore. That was for the previous video to demonstrate what orthographic was about, and yeah, I'm happy with that. So now scroll back up. I'm going to create some function prototypes up here. So we're going to do void key callback, and this is where the framework specific code starts coming in. Again, feel free to check out those links and replace any of the framework specific code with the framework of your choice. glfw window, and we're going to see what key has been pressed. We're going to have a scan code, which is something that glfw uses, the action, and then the mode of input. I'm going to do void. What's glfw mode about? Oh, it should be glfw window, not just glfw on its own. Window should be okay now. glfw window, yeah, capital W. I mean, I'll put a capital W instead of a lowercase. I'm going to put scroll callback glfw window double x offset double y offset, and now we're going to do void mouse callback glfw window. I did it correctly this time, no uppercase. Window double x pause double y pause. So this is just the x and y position on our window of where our mouse is. We're actually going to be hiding the mouse cursor to provide a more immersive experience, because it's one line of code, so you can easily change it if you want to. Now, one final method prototype, and it's going to be void do movement. So this is just going to be called every single frame, and this will just move our camera. Even if we haven't done any movement, it'll still be called, but it won't obviously move our camera. And now we just need to initially set some values up for our camera. So we're going to do camera. We're going to create a camera object, and this is going to be glm : vec3 0.0f 0.0f 3.0f. So these are just the initial values, and this doesn't like something about it. What's it saying? No matching constructor for initialization of camera. We've got camera, glm : vec3. Then we got our three values. Got a semicolon at the end. Let's just try running and see what would happen. See if we get. We've got a bunch of other errors. Unqualified ID. Forward references to enum types. What? I literally used this. So enum camera movement. I don't see what is wrong with that. We've got a bunch of stuff, so let me just what is wrong with it? Oh, spelled incorrectly. Let's change the ones that we can easily change. This picture, oh, there should be an equals here. There's bound to be a whole heap of errors. Put a semicolon here. Okay, so let's run it again. Let's see what errors we got now. Fix quite a few errors. It mainly seems to be to do with this enum camera movement. For some reason, it does not like this whatsoever. One bit. Expected unqualified ID. It does not like it whatsoever. Let me try this. Okay, I think that error has now gone away. So let me just, that should be uppercase pitch. I need to change this to camera movement. Run this again. Build succeeded. That's fine, obviously, still showing the same thing. Let me get rid of Safari, which is trying to do that Mac OS Sierra stuff. Okay, so we got that working. So that is weird. I'm going to try it again. It's going to be cheeky. Underscore. And I have no idea why it didn't work before. It must have been because one of the other errors was conflicting with this. So that is really weird, because I remember before this video I tried this code and it worked. So that is, I have no idea why that happened. That is just really, really weird. So now that we fixed any errors that we had in our camera class, I still might not mean that we've written the camera class correctly. I may have missed something out, slightly changed the value, but we'll find out when we run it. I'm going to put GL float, and this is going to be the last X position of the camera. So this is going to be, initially we're just going to make it equal to the center of the screen. So this is going to be our mouse movement. So we're going to put width divided by 2.0. We're going to put GL float last Y equals width 2.0 semicolon, and now in our int main, what we're going to do first of all is just scroll down, and yeah, we updated the get frame buffer size, which is fantastic. Now we're going to be actually setting the callbacks for this right here, all these function prototypes. We'll be implementing them later on. So what we're going to be doing is anywhere really round about here should be fine, anywhere after we do the window. We're going to do grfw set key callback, provide window, and then provide the method that we're using. So it's key callback, and I'm going to duplicate this 3 times, or we're going to duplicate it twice, so there's 3 instances of it. And we're going to put, instead of key, we're going to put cursor, pause callback, and we're going to change this to mouse callback. And for the final one, this is going to be set scroll callback, and this is going to be taking in the scroll method, so scroll right here. And the next thing we're going to do is do grfw set input mode window. The mode that we're changing is the cursor, grfw underscore cursor, and the value it's going to take is grfw underscore cursor, and we're going to put disabled. We don't want it hidden, we want it totally disabled, so our sort of mouse is just fixed to the center. It's just fixed within our window itself. We can't move out of it, but we'll have a key which will be escape to get out of our application, so we can actually, quit it without having to either do Control Alt and Delete or do something on Mac to get rid of our application. So now what we're going to do is scroll down. We've already added the depth test in the previous video. The shader files, so the vertex shader and the fragment shader, we don't need them whatsoever. Going to get rid of this particular vertex array. This was used for demonstrating orthographic projection. Not doing orthographic anymore. And I'm happy with this vertices array. I'm going to get rid of this comment actually. If I scroll down, because we're going to be rendering multiple cubes, what we're going to do is create an array of vectors, and this is going to be the cube positions. These are just arbitrary positions. You can chain them up, you can draw more cubes, do whatever you want, experiment with it. That's always the best way. And I forgot the colon. So the first vector is going to be glm vec3 vec3, sorry, vec3, and it's going to be 0.0f, 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 comma, copy and paste this. So there are a few instances, so we want 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And now let's start changing these values. 2, 5, -15. What I would say what would be really cool is once we've run this application and you watch this video, have a look at all the cubes and try and identify which one of these vector 3s applies to which cube. And that would be a great way of learning how this system works, how it all ties together in OpenGL, and the positioning, the movement, everything. That will be a fantastic way of learning. I mean, -2.5, -3.8, -3.8, -2.0, -12.3, -12.3, 2.4, -0.4, -3.5, -1.7, 3.0, The next value is negative 7.5. And there's 4 more vectors left. It's going to be 1.3, negative 2. Now there's a lot of code in this video, and this video is definitely going to be very long, but the results are going to be amazing, and it's going to set you up in a very good position for not only future videos, I mean, I would say future projects and just things that you want to implement in general, because having a camera system is really useful, especially considering the next few videos are going to be covering lighting. So it's going to be great to be able to move around the scene and see how lighting affects our objects differently. So what we're going to be doing is 1.5f, 2.0f, negative 2.5f, negative 1.5f. So do it the other way around this time. 1.5. Final value, final row is negative 1.3, 1.0, negative 1.5f. And now if we just scroll down, everything else should be a-okay. So let me just make sure, because obviously we've done all this work, we want to make sure everything's good. Got the vertex buffer object, got the vertex array, that looks fine, that looks a-okay to me. 5.0, I mean times it by 5 because there's 5 pieces of information. Yep, that looks all good to me. The texture stuff we're not changing, which is good. We've got a nice set of texture code that is very reusable, and we've set it to alpha always, so you can easily put a JPEG or a PNG or any format that is supported by Soil 2. Scroll down. We're actually going to be putting the projection inside of the while loop, and the reason for that is because we're going to be changing the field of view using the mouse scroll. We want to be able to update the projection every single frame if we're if we're actually changing the field of view value. But what I'm going to do in the next video is, like I said, remove that code from the camera class, because it's just for demonstration in this video, and take out the projection class as well, the projection code as well from the while loop. Keep moving. Projection equals. And before I move it, there are a couple of things that I need to change. I need to do GLM perspective. I need to do, it needs to be camera object, get zoom, screen and width is fine, the near and far clipping planes are fine as well. You could actually abstract these out as well, the near and the far clipping planes, into your camera class. Actually, I think that's a pretty good idea. You could do that as an extra task, because at the end of the day, you're probably not going to be changing that up. Just keep it in the camera class. That's probably the best place to put it. So let's just whack it in here. So if we just whack it down here, first of all, what we're going to do is set the frame time. So we're going to do GL float current frame equals GLFW get time. Again, there's links in the description for GLFW if you want to learn more about the get time stuff. There'll be links for SDL and SFML as well. So we're going to put delta time equals current frame minus last frame. So this is our way of detecting what the sort of time was between frames, because if, let's say, our current frame is at time 100 and our last frame was at time 80, ignoring whether seconds, milliseconds, whatever, the time between the last frame and the current frame will be 20. So that's what we've just done. And this is moaning because, well, I haven't created it. This was meant to be created above, my bad. If I scroll up, I missed this out. It's meant to be here GL because this is going to be used in the callbacks. GL float delta time initial value will be 0.0f. GL float last frame is going to be 0.0f. Now let's scroll down to our while loop. Where are we? Yeah, we was at the start right here. So the errors disappeared. We're going to do last frame equals the current frame. Obviously now the last frame will be the current frame when we restart this while loop on the next iteration, because obviously we'll have a different frame at that particular moment. GL poll events, after we've handled all the events, we're going to do. We're actually going to handle the movement. So do movement, semicolon, and we're using our shader. We got the texture. That's all good stuff. We got our projection. So we're gonna I just want to make sure everything's all good here. So we got our view. For the view, we're gonna change this up a bit. Instead of translating it ourselves, we're gonna let the camera do it. So camera dot get view matrix, and for the model, we're actually going to be getting rid of that because we're going to be putting that inside of a for loop, which will iterate over our cube position array and draw the objects in different locations and use the model using sort of a random rotation. So we got our camera get view matrix, that's fine. The view location is fine, projection is fine, but we can should I get rid of it or should I cut it? Because at the end of the day, the code is going to be essentially the same. I'll cut it when I need it. That's what I'll do. So the bind vertex array, that's fine. But we're going to get rid of this. Oh, we'll cut this because we're definitely going to be needing that. And in between binding the vertex array to the vertex array object and unbinding it essentially, we're going to put for. And in here, I'm going to put GL UN, so unsigned int I equals 0, while I is less than 10. So this is the size of the array. Obviously, actually, I recommend trying to make it dynamic. So you can just add more cube positions and you'll just draw more cubes. That'll be another great task for you. So first of all, we're going to be calculating the model matrix for each object, and then pass it to our shader before we start drawing. But I'm going to copy and paste this in here because this is going to be the last piece of code. So I'm going to do GLM : 4x4 matrix. So map for model. And now what we can do is do model equal GLM : translate, and for this we're going to specify the model that we just created, and for this we're going to put cube positions, and we're going to put I so we get the position that we want for this particular cube. GL float angle, and this is going to be equal to 20.0f times by whatever number the iterator is. The reason we're using 20.0, that's just a calculated value that looks pretty good. Vary this value up, see what happens. You might find a better value than this one. We're going to put, now we're going to be doing GLM rotate, so model equals GLM : rotate model, and for the angle I'm going to specify angle, which we just created, and for the vector we're going to put GLM : vec3 1.0f 0.3f 0.5f. And now finally we can copy and paste this uniform matrix. Which one we want? We want this one. We don't need to actually change anything from here. I'll just paste it into here like so. And we are actually done for our main. So if I, you know what I'm going to do? I'm going to add a bunch of blank white space here. So outside of the while loop, yeah, this is outside of the while loop. We're deleting the vertex array, deleting the buffers, and we're terminating GFW. That's all good. Now we can start implementing those function prototypes. And that is the last thing, and then we can run and see all the million errors that we have. So we're going to do void do movement. And this is just going to be handling our movement and calling the appropriate keyboard method in our camera class. So this is not going to take any parameters. We're going to do if. I'm going to use the WASD and arrow keys, but you can easily take out WASD and arrow. Again, this is using GFW, but you can easily modify it for SDL and SFML or any other sort of framework input method you're using. Going to put keys, GLFW underscore key underscore W, or keys is GLFW underscore key underscore up, and in here we're going to do camera dot process keyboard. For this it's going to be forward because we're moving forward. Delta time, which we've already calculated in our while loop. So this is the code for moving forward, and this doesn't like something. What does this not like? What's there not to like? Let me zoom out. Use of undeclared identifier keys. Have I missed out another parameter? Let me scroll up and see what have I missed out now. So, well, for starters, there should be a semicolon there. And yeah, I don't know why I did this. I didn't quite complete this code. There's meant to be a bool of keys. Let me move over slightly. Bool keys. And this is going to be 1024. It's going to be an array of 1024 different types of keys. I'm going to do bool first mouse equals true. So we're only obviously handling one type of mouse. So yeah, finally, that's all good now. We can actually just copy and paste this 4 times. Or 3 times, so we have 4 instances. The next one we're going to handle is S, and this is down. I'm going to put down here. Oh, backwards, sorry, because we're not going down, sorry. It's not up or down, it's forwards and backwards. This is going to be A, which will be, can you guess? A is left. Left. And now finally we can handle D, which is right. So now we're going to do a callback. So void key callback GLFW window, and this is going to have the window, the key, int, scan code, int action, int mode. Don't worry, we're almost done. There's just this method and 2 more to go. Probably about another 5 minutes, and we'll be ready to run and see our glorious code running. So forgot a comma here. We're gonna do if GLFW underscore key underscore escape, and the action that we want to detect on is action equals glfw underscore press, but there are other methods as well, like underscore release, repeat, and there will be similar methods in SDL and SFML. Not that one, it should be pressed, sorry, so press, and in here all we're going to do is glfw set window should close, so we specify the window, and the value is gl underscore true. So this will exit out of the while loop after this iteration, and then you'll clean up and we're done. If key is greater than or equal to 0 and key is less than 1024, then we're going to detect what type of action we're doing. So if it's glfw underscore press, one thing this should be glfw key escape equals key, sorry, and I wanted to use Yoda conditions. I know some people don't like them, but I do love Yoda conditions. So glfw press equals action, then we're going to be setting the keys, like the actual key that has been pressed, to true, else if, can you sort of guess what we're going to do here? We're going to detect if it's being released, and if so, what we're going to do is set that particular key to false, equals false. So this is where we would actually be using our keys. It's checking, is this key true? If it is, then this particular method has been called. If it's not, or if you've let go of it, then this particular piece of code has been called. I meant code, not method. And now we can do the void mouse call back, and this is going to be glfw window, didn't want to work, glfw window, and this is going to be double x pause, double y pause, and in there we're going to do if first mouse, we're going to do last x equals x pause, last y equals y pause. Very simple stuff here. And we're going to set them first mouse to false. We're going to do gl float. What are we doing here? X offset equals x pause minus last x. Oh, no, we're not doing any shader texture, no, sorry about that. It should be last x gl float. Now we're going to be calculating the y offset, so this is going to be equal to last y minus the current y position, so we can get the offset. Again, very simple stuff. So this is reversed because the y coordinates start from the bottom left. They go from bottom to left. Yeah, those warnings are just because we haven't used them yet. We'll do last x equals the x pause now. Obviously, on the next iteration, these particular current values will be the last value, equals y pause camera dot process mouse movement x offset Y offset. And now that is the mouse callback method done. We can do void scroll call back. This is going to take a few parameters. GFW window asterisk window double X offset double Y offset, not offset, offset. And in here, we're going to put camera dot process mouse scroll, and for the offset, we just put Y offset. We're ready to see if this works. So run it. Both succeeded, so that's obviously good. We've got our multiple cubes created, so that's good. We can look around, that's good. And we can move. So we finally have it working. I'm using the W, A, S, and D keys. Now I'm using the arrow keys. So they work just as well. So we can move sort of not just forward and backward, but forward and right, forward and left, back and right, back and left. And what's great about this camera system is the forward is relative to the way we're looking. So if I look at that particular cube there and I'll press forward, it goes towards that cube, which is fantastic. If I look at that cube, it goes forward. Let's see what happens if we try and go through it. Oh, we've gone through it and we can see the inverse of the textures. Like so. And the reason we can go through it is simply because there's no collision detection, and this video is not doing any collision detection. This is simply creating a camera class and implementing it, and we've got this really awesome sort of world now because we can move around it. This is just fantastic. This is going to be looking amazing when we get into lighting, especially when we get into, because the next video is going to be covering colors. When we get into actual basic lighting and some complex lighting, it's going to be fantastic to be able to look around the object and see certain aspects of it being dark, certain aspects of it being light. At the moment, we've just applied a texture and we have no concept of lighting, no concept of light and dark. So that is it. And now if I click escape, before I click escape, as you can see, you can't see any mouse. And if I keep scrolling left, you can, as I keep moving left, it goes all the way around, same for the up as well. But what I'm going to try and do is demonstrate. So I'm going to keep scrolling down. I can't go any more down, so I can keep rotating. As you can see, I'm rotating in one direction, but I can't keep scrolling down. But I can scroll up. Now I can look to the left. And the same principle is if I look up, I'm constantly moving my mouse up, but I can't actually go any further. I can look back down, but for the left and right, you can flip back around. I recommend actually just seeing what happens if you remove that pitch constraint. So now if I click escape, it is now done. Yeah, keeping Chrome, definitely. So that is it. That code, I was surprised that that code actually worked in that, all that code that we just implemented, that there wasn't any sort of mistakes below the bar the camera class. It all just ran first time, which was fantastic. It's always good when it works. So this has been a simple video, but there's been a lot going on here. So feel free to check out learnopengl.com, open.gl. There'll be links in the description. There'll be links to the where you handle time for the frame for the delta time in the description for all the different frameworks. There will be links in the description to handling input for all the different frameworks. Plus there'll be a link to the GitHub source code. Feel free to check that out if you're having any mistakes. You can compare the code. If you want to sort of skip this and just go directly to the code, feel free to do that as well. If you have any questions, feel free to comment, feel free to post them on our education platform, sonarlearning.co.uk. There'll be a link in the description to that. If you like the video, please give it a thumbs up, hit that subscribe button and leave us a comment. And as usual, Thank you for watching, and I hope you have a great day.